Stress-free learning with
Inonyam.
create a better tomorrow. You with the program. Hard work pays off, so come and put it in. No need to wait, let the lessons begin.
Look in the mirror. That's the person that you should be competing with.
Boom. Okay, let's get started. Today, what are we doing? Today we'll be doing three things in this video. What are we doing? We're doing compound angles, double angles, and general solutions. Okay? So general solutions, you should remember that you did that in grade 11. You should remember some part of general solutions, right? Compound and double angles. Let's look at that. Let's look at what's happening with that, right? So what are double angles? What are compound angles, my bad? What are compound angles? Compound angles, there's 4 of them. And this is what they look like. It says cos A minus B. What does cos A minus B equal to in a compound angle? It becomes cos A cos B, and then the sign in between changes to plus sine A sine B. So what changes here? The sign in between the cos A when it's 1 is it's a negative, but when you spread it out it becomes plus, right? So let's look at the next one, right? The second one. If we're looking at cos A plus B, what does it become? What do you think happens? What do you think is the sign in front of that? The sign is obviously negative because the sign changes. It's the opposite sign, right? So it becomes negative and everything else is the same. Everything else still looks the same, right? So those are the first two, right? Those are easy to remember, right? Oh well, if those are easy to remember, the next ones are even easier. So the third one, sine A plus B, right, is equal to, what is that equal to? So for this one here, it's equal to, the difference with this one here is, instead of it being the same sign on both sides, it's different because we have cos B. We have sine A and then cos B. But then the part that doesn't change here is the sign. So instead of it being sine A again, it will be sine B cos A. Right? So the sign in between does not change, but the angles change, and the sine it's sine and cos, and on the other side sine and cos, but with different angles, right? So the fourth one only so means that the fourth one would be sine A minus B, and I'm pretty sure most of you can already guess what the fourth one would look like. It will be sine A cos B minus sine B cos A. As you can see, this makes sure that sine goes as it looks at angle A and looks at angle B. So if you see your equation and you have cos A, and then on the other side you still have cos A, it means that the other angle you did not take into account. So it has to be cos B and then cos A, or vice versa, whichever way, right? So these are your 4 rules for compound angles, right? These are your 4 compound angles. So now let's do an example to see what I'm talking about in a better way, right? So let's do this example. Example 1 says simplify. Says simplify A, right? There's 2 examples. Cos of x plus y and sine P plus Q, right? These are my 2 examples. I want us to simplify this. So again, if you don't have your exam pad or your book, go get it. Get a pen, start writing. Let's get to doing some work, right? We're not just sitting here. We're not watching. This is not for leisure. Let's do some work. Let's get that A for maths that we want. Okay, so let's start. A, how do I solve A? what I do is I say cos x plus y. What is cos x plus y equal to? If I look at my rules, which rule is it? It's between the first one and the second one, right? So, but which one is it?
The truth of the matter is, you have to enjoy the journey more than the destination. So enjoy your matric year, but get your results first. Get your results, work hard, but also enjoy your year, because you don't want to regret not enjoying your final year in high school.
Over here, there's a plus in between, okay? So you don't even need to look at the top of it. If you know that there's a plus in between and it's cos, it means that the negatives, the sign in between will change, will be opposite. So instead of being plus, it will be negative. So how do I write it? It becomes cos x, cos y, minus sine x, sine y. So if you look at your rule at the top, it matches up to see that's how it changes. That's the only thing that changes is the sign in the middle. Let's look at example B, right? Sine P plus Q, right? Sine P plus Q. What do we know about sine? We know that the sign doesn't change in between, but the angle, it varies. It goes sine cos, right? So let's see what it says. So it becomes sine P cos Q, right? The sign in between does not change. So on the other side, has the cos been used with the angle P? No, it hasn't. So we write cos P sine, what's the other angle that's left? Q, right? So sine, it says sine P on this side and it says sine Q on that side. It says cos Q on this side and it says cos P on that side. So both angles have been used. So that's basically example 1, showing you about compound angles. So with that in hand, let's look at example 2. Let's look at numbers, right? So let's look at numbers so that we can see what it looks like as an exam question, for example, right? So let's look at example 2. Let me write it on this side, right? Example 2. Example 2 says cos 75. Simplify with no calculator, right? That's the important part. Simplify with no calculator. How do we go about solving for this? First of all, we just look at what we have just learned now is exactly what we're going to apply to this, right? How, you ask me, how do I apply what I just learned to do that? That looks complicated, doesn't it? No, it doesn't. It's not complicated. If you look at it and you look at the angles that you can work with, the angles that you know, because most of the time when they ask you to work with no calculator, they mean that you must calculate, you must use like the special angles, right? Because they know that those are the ones that you should know. They expect you to know those. So if I try, let's say, what's 30 plus 45? 30 plus 45 gives me 75. So therefore, I can work with that. So let's try it out. Let's say cos 30 plus 45, right? Cos 30 plus 45. Okay, when we're looking at it now, does it look similar to something? I think you should be catching up. Yes, it does look similar to something. It looks similar to that rule that we wrote at the top, at the number 2 over there, cos A plus B, right? There's a plus in between. What do we know about cos? Cos, the sign in between changes and it becomes negative in this case, right? So now let me see, what do we start with? We say it's cos A, right? So cos A, what is A in this sequence, in this sum? It's 30. So it'll be cos 30. It'll be cos 30 cos 45, right? Because it says it's cos A and cos B, isn't it? If you look over here, cos A and cos B. So therefore, the second part again, what did we say? The sign changes, so it becomes negative. So on the other side, it's sine 30 and sine 45, right? So it's sine 30, sine 45. So basically, we have figured out what they're trying to teach us in this thing. That's basically it. From here onwards, it's just a matter of you remembering your triangles, your special angles, right? So I'll use my 30 and triangle, my 30, 60, and my 45. If I do that, what do I get? I will get, for this cos 30 becomes root 3
over 2. Right? Okay, this is what I'm talking about. These are the special angles I'm talking about. $90, this is 90, this is 30, this is 60. Right? These are the special triangles that I'm talking about. These are the ones that you use to figure out what cos 30 is, what cos 45 is. So the values are, this is 1, this is 1, this is root 2, this is root 3, this is 1, and this is 2. My bad, my 2 looks amazing right there. That's a 2 there, right? So these are the ones, you're supposed to have this committed to memory. You're supposed to remember these. They're not going to give you these. You're going to have to know them. Or if you know a way around, you can use the calculator. But be careful. Be careful when using the calculator. Because you might get the marks, you might get it wrong if you don't use it right. So let's put it in. So if I say cos 30 is 1 over. Sorry. My bad. I put the wrong angles. This is 45. This is 30. And this is 60. Okay, now those are the right ones. The ones before were the wrong ones. Okay, so now if I look at it, it says cos 30. Cos 30 is root 3 over 2. You can put that in your calculator and see if it is correct. And then you say cos 45. What is cos 45? It's equal to 1 over root 2, right? 1 over root 2. Minus sine 30. What is sine 30? Sine, opposite, 1 over hypotenuse, right? Sine 45. What is sine 45? Opposite over root 2, right? So that is basically what you have now, right? So now it's a matter of solving your equation, right? So if I solve for this, it will become root 3 over 2 root 2. Why do I say that? Because root 3 times 1 is root 3, right? And 2 times root 2 is 2 root 2. That's a 2. Minus, on the other side, we say 1 times 1 is 1. So at the bottom is 2 root 2. Why? Because 2 times root 2 is 2 root 2, right? Now this is equal to, what is this equal to? What do we see there? We see a common denominator, so we can add what's on top. But root 2 minus 1, we don't know what that is off the top of our head. And it says we can't use a calculator, right? This is very important, we can't use a calculator. So what do we do now? We just write it under one denominator. So it becomes root 3 minus 1 over 2 root 2, right? And that is your final answer. So you can leave it in this form here. Because if you had a calculator, you might have been able to simplify it. But since you can't use it, we'll leave it like that. Okay, so now let's move on to double angles. Double angles. Okay, so double angles. What are double angles, right? There's two types of double angles. There is the cos 2a and there is sine 2a. Okay, cos 2a has a couple of variations. Why? Because we can substitute sine squared theta plus cos squared theta to make it look different, but it's still the same thing. So this is the first one. Cos 2a is equal to cos squared a minus sine squared a, right? That's the first variation of the cos rule. So all you need to remember is the first one, and then the other ones you can just change them by using the variation, right? By adding in, like cos squared, like this first one, the first variation. If I want to change this, right? If I want to get rid of the sign, what do? I make the sign look like 1. So I want to get rid of the sign, right? Sine squared a is also equal to 1 minus cos squared a, right? Do you agree with that? Because if I put 1 over here, if I put sine squared theta plus cos squared theta, cos squared A minus cos squared A cancels out, and you are left with sine squared A, right? So that's why in this we can have the variation that goes like this. It goes 2 cos squared A minus 1, right? Right? So if you want to prove this for yourself, you can prove it. Substitute over here, instead of cos squared A, you can write 1 minus sine squared A. Then you see how you solve it out, and then that's how you get the other variation, which would be 1 minus, boom, okay, minus 2 sine squared A. Okay, my A is a little small. Okay, sine squared A. So those are your three variations for cos 2A, right? So now let's look at the second one. The second one is sine 2A. Sine 2A can have different variations, but it really is just one variation that we have to look at, which is 2 sine A cos A, right? So this is the variation that we have for sine 2A. This is what it will look like, right? It can also be written another way, right? It can also be written as sine A cos A is equal to half sine 2A. Why? Because I can just divide by 2 on both sides, and then it'll be just sine A cos A. This is what I'm talking about. This is not a variation, but it's a way, like they might put it in a way like this in a question so that you don't understand what they're talking about. This is what I'm saying. You can write it as sine A cos A is equal to half sine 2A, right? This is still the same thing as the one above. Why? Because if I multiply both sides by 2, it will return back to the original state. So yeah, that's basically it for double angles. Let's do an example. So that let's do an example. Alright, so an example, right? Where are we gonna do the example? Let's just do the example right next to it right there. So example 1 for double angles. What is example 1? Example 1 says calculate what sine 120 is without the use of a calculator, right? Sine 120. Calculate. Right? That's what we want to calculate. We want to calculate what sine 120 is without the use of the calculator. So what do we do first, right? That's the question. So since this is under double angles, you can already tell, hopefully you can already tell that you have to half that, because we are dealing with double angles. What is double? Double is 2, right? That's why we have 2A. Over here 2A, right? So this one, yeah, since it's under double angles, you have to be aware to this in the exam paper, because you won't be told that it's a double angle. You have to tell, you should be able to interpret it on your own. So like this, for example, this becomes sine 60 plus 60, right? It becomes 60 plus 60. That's what it becomes, which is the same as 2 times 60, right? So I can rewrite it and write it, which is equal to sine 2 times 60, right? Now it looks a lot more familiar to these double angles, right? Because it's 2A. So whatever angle A is the one that we use to make it look like that, right? So now what do I do after that? Now what I do is I can say this is equal to this 2 sine. What is A in this instant? The A is 60, so sine 60. Cos A. What is A again? It's 60. And there you go. You have your value there. That's 2 sine 60 cos 60. This is the difficult part. Once you have done this, the equation is easy. Now it's just a matter of, again, using your special angles. What are your special angles? You should remember them. I just erased them. They are just, if you just rewind back, you'll see what they are. Which is equal to 2 sine 60 becomes root 3 over 2. And cos 60 is the same as half, right? Again, you can put these in your calculator to try it out to see what it looks like. Although it says without the use of a calculator, You can try it out and put it in your calculator, but again, be careful what you get. Remember, if you get root 2 over 2, you do not write root 2 over 2 because that is rationalized. And if it's rationalized, you can't use it because they will know you use the calculator. So we have to write it as 1 over root 2, right? That's just an example. So be careful when you use the calculator. So now once you have that, now basically what you can do is you can cross out this 2 times 2 and you are left with what's root 3 times half. Root 3 times half gives me root 3 over 2. So that is my answer. No, my 2's are giving me a problem. Okay, that is my final answer. If you have the mentality that everything is your fault, this gives you control. It allows you to say, since it's my fault, I can do something about it. Not just it's my fault, so therefore I can't do anything about it. If it's your fault, that means you have control. You can do something about it. You can go and change that, whatever that is the problem. This wasn't too bad. This was pretty straightforward if you ask me. Yeah. So you should be able to do this now. So practice. And you have these things, you understand them a lot better. Okay, so now we'll be doing the last part of this video. The last part of this video is what? General solutions. General solutions, I don't really need to go much into detail or speak about them because you did them before. I'll just do one example to revise or revitalize. That's a nice word. To revitalize your memory so that you remember what general solutions are. So my example is example 1. Example 1 under general solutions. Yeah, so example 1. What is my example 1? It says find the general solution for solution of sine 2x is equal to cos x minus 10, right? That's my question. Find the general solution of sine 2x is equal to cos x minus 10. So since this is my question, what do I do first? What do I know about general solutions? General solutions, I have to look for reference angle before I can start doing anything, right? So in this instant, yeah, this looks difficult, doesn't it? If you get this is very likely. You might get this in your exam. It looks very difficult, but really it isn't that difficult. It's pretty straightforward. So what do you do first? What I would do first is use core-ratios. You asking, why would I use core-ratios? Because I want to make sure that, because I can't divide sine on that side. I can't say cos inverse and then make that sign disappear. But I can say cos inverse from this side onto that side to make that cos disappear. So what would I do? So this is how I'll write it. I'll say, so sine 2x is equal to cos x minus 10, right? So I want to change this sine 2x into a correlation, into a cos. How do I do that? It becomes cos 90 what? 90 minus 2x, right? Why 90 minus 2x? Because if I said cos 90 plus 2x, it would have resulted in a negative sine 2x. But I do not have a negative sine 2x. I have a sine 2x that's just positive, right? So that's why I use cos 90 minus 2x. Because if you remember from the core-ratios that I did a while back, cos 90 plus theta is the one that changes into a negative sine 2x, into a negative sine theta, right? So now I have done that part. So once I've done that part, I have done the complicated part. From here onwards, it's pretty straightforward. Why? Because now I can just look cos inverse both sides. Why? If I do that, if I cos inverse both sides, it will eliminate the causes, right? So what would I be left with? 90 minus 2x is equal to x minus 10. Okay, that's not looking too bad. So normally I would solve for this and then find x is equal to, but you shouldn't do that especially when you have a coefficient of x, like as we have right here. So what I would advise you do from here, you plug it in to how you normally get the general solution. So from here, what you would say is 90 minus 2x, 90 minus 2x is equal to x minus 10. This is for the positive. So when cos is positive, this is what we're doing here. We don't change anything, we write it as it is. Like, for example, like if this is in the first quadrant, there will be no change in anything. We don't add, subtract 180 plus 9, nothing like this. So we just write it as it is. But since this is a general solution, we have to write plus k360. K is an element of z. Right? Remember, this is very important. You have to write that. Otherwise, you will lose a mark or something like that. Why would you lose a mark for something you can just put there with no effort? Right? So now once we are, now what we do? Now we solve for it. Right? So we solve for it. So what do I do first? I want to take my 90 onto this side, and then I want to take this x onto the other. Look at me. Look at my eyes. Look. Side. So it will become negative 3x is equal to, if I take 90 onto this side, it becomes negative 100, right? Plus k360. K is an element of z. So you have to continue to write that for all of them, all the way to the bottom until you got to the final answer. So now I have this. This is exactly why we didn't solve this, because we want to, when we're dividing by 3, we do not just divide the 100. We divide everything by 3. So this is what I'm talking about. So it will be x is equal to 100, negative 100 divided by negative 3 gives me 33.33, right? Yes, degrees plus k 120. K is an element of z. So as you can see now, it's no longer k 360, it's k 120. Why? Oh, it's not supposed to be positive either, because divided by negative 3, right? So it'll be k 120. As you can see now, this is the final answer for the positive, when it's positive. So positive, right? So when it's negative, what do we change? We change what's on that side, right? I will change what's on that side too, so that it's negative. So it'll be 90 minus 2x is equal to, so what do I change? I just put a negative sign in front of the x minus 10, right? So now this one here is to take into account for when it's negative, right? So when it's negative, so this part here is still the same. K 360, K is an element of z, right? So you continue to write that again. So now what do? Again, this is easy. I just solve. I'm just solving, that's what it is. So if I multiply this negative on the inside, and then I take that negative onto the other side, this becomes negative x, right? So I have here negative x. Okay, let me just write it out. So I have 90 minus 2x is equal to negative x plus 10 plus k 360 k element of z. So now, okay, there we go. Now let's look at it so that we all on the same page. Now we have negative x, positive 10, right? So if I take this x onto this side, it becomes positive. So this is just negative x, right? Is equal to, if I take this 90 onto that side, it becomes 90. It becomes 10 minus 90. So this is negative 80. Because 90 goes onto that side, it becomes negative, right? Plus k 360, k is an element of z, right? So x is equal to 80 minus k 360, k is an element of z, right? So this is my final answer. So this is what I have. So this right here is my reference angle. That's why I didn't solve for it. That's my reference angle, right? So when you have something like this, do not solve for it. Just go with it in there, and then once you have it there, just make a positive one and a negative one, right? And solve for it. Don't forget the k is an element of z. And that's basically it for general solutions. So you should have the understanding of general solutions, and you should go and practice some more examples. So go check out the next video. Let's go to the next video. Let's finish this. Boom.